So far in our work with calculus, we've done quite a bit of work with the tangent. So we're familiar with this idea of a straight line touching a curve at a single point. What we're doing now is introducing the idea of a normal. And a normal is simply the straight line that is at right angles to the tangent at a certain point. So on the function here, we've just got x squared in blue, which is a fairly familiar function to us. We've got a tangent at x equals 1, and that's shown, at x equals 2, and that's shown in the purple. And then the normal is the right-angled line, the red line going through both the curve and the tangent. So what we're doing now is working out how do we work out what the equation for the normal is if we know the equation of the curve and our point of contact. So just definition-wise, the normal is at right angles to the tangent. And quite specifically, it goes through the same point. A little reminder about lines and perpendicular lines. So if we've got lines that are perpendicular, they have gradients which are negative reciprocals. In other words, if you multiply the two perpendicular gradients together, the result will always be -1. That was part of the recap stuff that you did at the beginning of semester 2. All right, having a look at our examples, I've done all of the working for you in this one, and rather than talk you through every single line, I want to show you what the steps are, because there's certain steps that you must do in order to get the correct answer, depending on the exact question. So the first one, example 1, is asking us to find the equation of both the tangent and the normal. So first, and the curve is x squared. So in actual fact, it's the graph that we were just looking at the point of contact x equals 2. So the first thing we need to do is find the point of contact. We've got our x coordinate, which is 2. So we sub it into our actual equation to get our point of contact at 2, 4. Then we find the slope of the point of contact. We're not given any instructions about using first principles, so don't use first principles. Use the rules that we've learned in the last lesson. And just a quick reminder on that, if f of x equals x squared, then f dash of x, the 2 comes down as a factor, x, 2 minus 1 is 1, so our derivative is simply 2x. Which is what I've got written here. From there, we want to find the slope at the point of contact, so we find f dash of 2 and tells us that the slope is 4. From there, we find the equation of the tangent using y equals m outside of x minus x1 plus y1, or whatever variation of that rule you feel most comfortable with. Either way, you should end up with the equation of the tangent. That bit we're most familiar with so far. All right, finding the slope of the normal is the next step. Recognizing that to find the equation of any straight line, we have to have a point and a slope. We can find the slope from 2 points, but at the end of it, we have to have a point and a slope. So the slope of the normal we find by taking the negative reciprocal of the slope at the tangent. Our slope of the tangent was 4, so the slope of the normal is -1 on 4. Please be sure that you are confident in taking the negative reciprocal, because if you get the wrong slope there, you will get the wrong answer altogether. Once we've got the slope of the normal, we've now got the two things that we require. We've got the slope of the normal, which is -1 on 4, and the point that the normal is going through, which is 2, 4. And so we sub those in here. Here's our point 2, 4, and our slope -1/4. So then we go through and calculate find the equation of the normal. So this is the equation of the normal in slope-intercept form, which is totally fine unless otherwise specified. And all I've done here is rearrange it into general or standard form. Not for any particular reason, just because you can if you wish. Unless it's specified. So from there we conclude we need to state quite specifically that the tangent is this function and the normal is this function. You can't just write down the two equations of the straight lines. You must be very clear about which one is which. And that is the situation that was graphed up here, and you can see that this is the tangent that we just calculated, and this is the normal that we just calculated. In the next video, I'll go through example 6.2.